Hey there, CJ Math students. Welcome to class for homework 6.5, angles and triangles. So, triangles are made up of three sides and any three angles. In order for a triangle to be formed, the sum of two sides must be greater than the length of the third side. I will show you exactly what I'm talking about. So, pretend I give you these lengths, 13, 7, and 5. In order for this to form a triangle, I can add up any two numbers out of those three, but they got to be greater than the third. So 13 plus 7, yeah, that's 20. That's greater than 5. We're good. 13 plus 5, that's 18. That's greater than 7. We're good. But if I add 5 and 7 together, I get 12, which is less than 13. So no, this set of lengths cannot be a triangle. Let's try it again. 1 plus 1, that's 2, but that is less than 2.5. So no, I don't even have to add up any of the other sides. As long as I come across one set of numbers where if I add two numbers together and they're less than the third, it can't be a triangle. Let's do set 3. 4 plus 6, that's 10, so that's greater than the third number, 8. 4 plus 8, that's 12, that's greater than the third number, 6. What about 6 plus 8, that's 14, that's greater than the third number, 4. So yes, this can be a triangle because I was able to add any combination of those three numbers, and two of them were always greater than the third. Next, let's move on to talking about the inside of triangles. So the sum of three angle measures in a triangle always equals 180. We know this, we talked about this yesterday, right? If you unfold the triangle, you get a straight angle, which is 180 degrees. So in order to prove it, we can just go ahead and say, hey, if I give you two angles, I know the third one added to those two have to equal up to 180. Just do the opposite of addition, which is, let's just subtract. So I can do 180, subtract off the two angles that I know, so minus 37, minus 81. When I do that subtraction, I should get my third angle, which is 62 degrees. That means that this missing angle right here is 62 degrees. It looks like in the next one that they only give you one angle measurement, right? So it's 180 minus 45, but then you're like, how am I going to figure out the other two angles? Well, first of all, you got this box here, and a box indicates a right angle, which we know is exactly 90 degrees. So in evidence, they actually did give you two angles. So 180 minus 45 minus 90 leaves you with 45 degrees. So this angle right there is 45 degrees. In triangle number 3, again, they give you two angles. So you say 180 minus 60 minus 60. Doing that subtraction gives you 60 degrees left over. All right, I'm going to have you do triangle 4 in Edpuzzle. So finally, triangles can be classified according to their side length and angle measurement. So let's first take a look at how we classify a triangle by side length. First, we call a triangle equilateral if all side lengths are equal. You would see this in geometry simply by, you'd see a triangle and they put tick marks just like this on all sides. Meaning, if this side was 4, then every other side with the tick mark would also be 4. Okay? Next, in an isosceles triangle, two sides out of the three are equal. So again, you'd see tick marks like this, saying like, hey, if this was 7, then that also is 7, but we don't know the length of the third side. Finally, in a scalene triangle, no sides are equal. So you might even see something like this. 1 tick mark here, 2 tick marks here, and 3 tick marks there, meaning that all those sides are different lengths. We can also classify triangles by their angle measurement. So an acute angle triangle, will have all angles in the triangle are going to be less than 90 degrees or acute. That means like, hey, if I said that this was 60 degrees, this would be 60 degrees, and this would be 60 degrees, right? All those angles have to be less than 90 degrees, and remember they have to add up to 180 degrees. Next, we have a right triangle. In a right triangle, there is exactly one angle that is equal to 90 degrees. Doesn't matter what the other angles are, as long as you got that one right angle, it is a right triangle. And finally, an obtuse triangle has one angle is greater than 90 degrees or obtuse. So if I, for instance, said that this angle right here was 120 degrees, then I would automatically call that an obtuse triangle. So you're going to use the notes on the front to help you out with the back. And on the back, you're going to do 3 things on problems 1 through 6. You're going to classify the triangle by its sides, by its angles, and then you're going to solve for x. So let's take a look at number 1. Number 1, I noticed that all the sides are equal. They have those double tick marks. If I go back over to my definitions, all sides are equal. That is an equilateral triangle. So an equilateral triangle is how I call this by its sides. If I take a look at its angles, all of its angles are acute angles. So anytime I have all angles that are acute angles, I will call that an acute triangle. And lastly, I want to solve for x. Well, here's what I know. If this is x, then everything else also has to be x. Why? Because the side lengths are all equal. If you have equal side lengths, you're going to have equal angle lengths as well. So basically, I have 3x, or 3 times x, has to be equal to 180, because I know all measurements inside of a triangle add up to 180. I divide both sides by 3. I will get my answer if x is equal to 60 degrees. Let's do one more. For number 2, notice there are no tick marks anywhere on this triangle. Now, when there are no tick marks, that usually means that none of the sides are equal. So no sides are equal. That is scalene. I'm going to look at the angle measurements. I see an acute angle, but I also see an angle greater than 90 degrees, which is obtuse. So just because there's only one obtuse angle, I call this a scalene obtuse triangle. And then if I wanted to solve for x, I'm just going to say, hey, all the angles have to add up to 180 degrees. So 180 minus 118 minus 34. And when I do that, I get 28. So 28 degrees. Okay. I'm going to allow you to solve the remaining ones. On number 5, don't freak out, because if you know that this is 61 degrees and this is x, we'll take a look at its sides. This is 10 inches and this is 10 inches. So that means 2 of the sides are equal. If 2 of the sides are equal, 2 of the angles have to be equal as well. Right? 7 and 8 you should be able to do very easily on your own. And then problems 9 through 12, you're just going to set up equations. So you'll notice that all 3 angles always have to add up to 180 degrees. So put down what you know. I know one angle is 65 degrees. You don't even have to put the degree sign, sorry. I know another angle is 90 degrees, comes from that box. And I know the third angle is 2x plus 1. And I know that all 3 of those have to add up to 180. So look for your like terms, 65, 90, and 1. Add those together, that gets you 156 plus 2x equals 180. And then we have our old friend, a 2-step equation. So we start off by subtracting the constant from both sides, minus 156. That's our first step, so we'll highlight that. Then we get 2x is equal to 180 minus 156, which gives you 24. And then we finish off by, I see multiplication, so therefore I divide. So x is equal to 12. Please write it nice and neat, just like I have. Circle the answer. All right, that's it. Please call me if you have questions.